union types. Let's just talk about what the heck that term even means. And we'll see how to use union types in Racket, in a dynamically typed language, much later in the semester. It's going to be weeks before we see examples of doing this in a statically typed language. We'll look at some Java and an OO approach, as well as something like Ada, how they do it. Okay, before we do that, I just want to real quick review. We need to know this. What are the steps of the design recipe we've been using that we introduced last time? And we saw last time we had steps 4, 5, 7, 8. And what were they again? Go ahead and sit down, pause the video, try to remember them, look back in your notes, look at an example, maybe look to see where they are linked from every single web page for the iTech 380 course. Yep, step 4 was write unit tests. Step 5 was, again, this rote sort of step of several small things that we're going to lump all together. And go ahead and write the purpose statement for your function. The signature, what types is it taking in and out? The header, that's just the define and the name of the function, getting the parentheses and the argument names, the parameter names. And then go ahead and stub it out, okay? So those are the little bits of step 5. Step 7 is the real work of complete the code. This is the one step that's not so rote. Again, why are we doing this design recipe? If nothing else, it's a way to get you from a blank screen to a lot of the code that you need until you hit step 7 of saying, okay, now put together the pieces that we have from previous parts and get a working solution. So, and we saw examples of doing this. We saw the example of the monogram function, I believe it was, and like pizza area, something like that, that took in a number or took in a couple strings or whatever. And we're going to go and I'm going to reveal that there's actually another step that we did here that we have sort of omitted. It was almost we took it for granted, which was before we even get around to writing the functions, we were saying, hey, I want to represent the area of a pizza. Let's write a function for that. And we came up with a signature of what type took in a double, a non-negative double, returned a non-negative double. Before we even write the code, we're thinking about what types will we use in our program to represent the things in the real world. So if I'm in Java and I want to represent a distance, I'll use double. I'll use the Java double, even though a Java double can be negative and I don't want to include negatives. But step 1 is data definition, okay? And with that, we want to go ahead and give examples of the data. Again, we almost sort of took this, or take this for granted. So, but these are the 2 new steps we're going to explicitly add this time. So here's an example. We're going to write a little function that has to do with, say, the users at a school, computer users at a school. I go to a school and I want to look up some information, and I want to look up what somebody's student's email is. And so I make a query and I'll get back something. So how do we represent their username? What data type should we use? So we have a built-in data type that will do it for us. Say we're going to use Racket. And whether it's Racket or Java or most any language, I think the immediate thought is string. I'm going to use a string to represent the username. Great. And now here's the nuance that I'm going to add about data definition. There's actually a difference between strings in general and what can be a valid username. Yes, every username is a string, but if I say, hey, write a function and it's going to accept any string in the world and process it, and I'm expecting you to give me a username, oh, that's a little bit of an issue. I don't want to say that I can handle every string in the world. I'm like, I want to handle only a username. Or conversely, if I write a function that returns a username and all I tell you is that it returns a string, well, there's actually a lot more information I can give you about what I'm returning. So I'm going to think of username as a more refined type than string, okay? And so if I want to ask what is a username, I might go and look up, ask the IT full, okay, what exactly is the thing? But it can't be the empty string. It can't be the string 70 years ago, because there's spaces in there and that's too long. And maybe we're going to go and assume here that we ask the IT department, and they say a string is one or more lowercase Roman letters, possibly followed by digits. Okay, so and the length won't be 14 or more. It will be less than 14, and it'll be at least 1. Okay, so let's go ahead and say I have that written down here using the half interval notation. Include 1, but don't include 14. That's the right notation to use when representing intervals in computer science. Okay, and what does that string represent? The interpretation is, of course, the characters in a username, somebody's username. Okay, so let's give some examples of this. So that's step 1. We just did step 1 of the design recipe. Like, hey, I don't even know what the function, and notice how this happens before I even care about what function I'm going to write. I'm just like, I know I'm going to be dealing with usernames. I need to define a type for them. And then I should give some examples of the data type. So here are some examples. And when I give examples, these are not just examples of usernames in the real world. These are examples of runnable code inside my program. Okay, so that's worth noting here as runnable code. Runnable, by what I mean is something that I could actually type into my source code. Okay, so it might be in Java, if I'm using some fancy data type that I need an object for, this might be a call to the constructor. Okay, but it's not just going to say, hey, here are some examples I'm going to write down that don't mean anything inside a program. No, my examples of the data type are examples of as represented in my program. And the data definition is how will I represent this data inside my program. Okay. That distinction is a little bit too easy with strings. We'll get some more interesting ones later. Okay, so that's an example. What else could you have? According, if this is what the IT people said, what else could you have? Go ahead and think of a couple more that sort of stretch some boundaries on what might be there. Go ahead and pause and give me 2 or 3 more examples that exemplify the possibilities in this definition we got from IT. Pause. Unpause. Okay. Yeah, so we had a string there of length 7. Could we have a string of length 2? Yeah, I guess if you had XY, I guess that could be somebody's username, matches this data definition. In fact, can I have a string of length 1? Sure, that matches. Can I have a string of length 0? No, that's not a valid username. Okay, so what else? Oh, there were digits, and I also want to stress the max length. So I might go ahead and say, hey, Z was followed by some digits, 2, 3, 4, 5, 6. Yeah, that could do it. Z, 2, 3, 4, 5, 6, 7, 8, 9. I want to stress the length going up to possibly 13. That's 9 digits. 10 digits, 11, 12, 13. That would be valid. I can't add another digit there. Now you may have been thinking, of course, hey Barland, I'm in computer science. If I want to count past 10 in hex and use a single digit, I'll go to Z, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. Now wait a minute, is that a valid username? And here's where I'm going to be thinking about this. I'm doing my thinking up front. I'm not saving this thinking for I'm in the middle of some function involving with usernames. I'm like, oh, it is this, no, oh, I looked back at what the person from IT said. Yeah, it has to be letters followed by digits, possibly. So I can't have the A, B, C, D there. Okay, but I could also have 13 characters that are all letters. 13th letter of the alphabet, M. Okay, there. I think this is plenty of things. I'm stressing out all sorts of different things here. And in fact, if I look at what I'm stressing out, this string of the length 2, I'm like, that's a little bit redundant, perhaps, but I'll keep it. No reason to delete it. Okay, that is step 1 and step 2 of the design recipe. And now we could go over and write functions that take in usernames or return usernames. Gosh, we haven't gotten to union types, have we? Well, I'm going to pause the video, and the next one is going to jump in and start with union types. If you want a little bit more philosophy, hold on for another 60 seconds here. Which is, if I'm saying that that username is a new type, rather than saying, hey, I have a function that takes in a string and a number and returns a Boolean, I don't want to say, hey, it takes in a username and a function and returns a Boolean. And that's when I say data definition, one thing I'm doing is, hey, this is a new name I can use in my program, and it's a technical term, okay? It is not just sort of a loosey-goosey thing, it's a type. If I'm in Java, what would I do? In Java, I'd probably have class username. And then username is an actual thing. I can actually say, hey, this function takes in a username, or it returns a username. And in Java, I'd have to make a class, even though it would be a class with only one field inside. It's a string. Yeah. But I could do that, and I would probably do that in Java. That's the right way to do this. You're giving a data definition. Okay, so yeah, do you want to go ahead and be able to ask, hey, here's a string. Is it one of these? I know it's a string, may or may not be a username. Could I go ahead and write a function called username question mark, just like we have built-in functions called integer question mark and string question mark and number question mark and Boolean question mark? Yeah, I could write my own functions, my own defined data type. I could write my own function called username question mark. And because I'd probably use regular expressions to write it. I'm not going to digress in doing that. But if you want to go ahead and write a function called username question mark because we've introduced a new data type username, yeah, more power to you. Okay, let's go to the next video and actually start with a user type that's going to include this as one of the variants.